This is simulated particle and antiparticle pair production, and it happened entirely by accident within our simulation at Optimum Advanced Study. I have the video on a loop to better isolate the phenomenon, but this simulation can be run indefinitely. You might have noticed that the simulated particles are a bit lopsided, but that's only because the edge of the simulator is wrapped to opposite sides to simulate in infinite space. And so these simulated particles are attracting to themselves through the wrap and warping in the process. Without the wrap, they form into perfect spheres. I will explain how it works, but first, you might have seen our physics simulation at Optimum Advanced Study, where we are, to my knowledge, the first to simulate the four forces of physics from one equation. And our first simulations were in 2D, seen here. So a natural question was, what happens when the simulation is run in 3D? So one of our researchers did just that, and before I talk about it, let me review how our equation works. Each coordinate within our simulation has a real number value between -infinity and +infinity. Those real numbers average with the real numbers and the coordinates directly touching them to conserve their sum value, and that process happens within each coordinate simultaneously each time step. That's it. That's our equation. We simplify that equation by saying that our simulated universe equals energy matter divided by space-time, or U equals E divided by S. The colors and arrows, called vectors, are derivative of the underlying real numbers. Generally, blues represent negative numbers and reds represent positive numbers, and the vectors simply point in the direction of greatest local real number change. Without the colors and vectors, all you would see is a grid of changing numbers, which is difficult to make sense of, so the colors and arrows are helpful. Okay, so that's what's happening within this 3D simulation too, only the numbers are averaging in 3 dimensions rather than just 2. When we first ran this simulation, we didn't understand what we were even looking at, until one of our researchers recalled the observed phenomenon of particle-antiparticle pair production. And well, I'll let TED Talks EDU explain.
If you concentrate a huge amount of energy in a tiny space, new particles will come into existence. If we look closer, we see that these particles always come in pairs, like twins. That's because particles always have a counterpart, an antiparticle, and these are always produced in exactly equal amounts, 50-50. This might sound like science fiction, but it's the daily life at particle accelerators.